All right. So global warming is that rise in temperature over time. Okay. Is it warmer in general the whole year? Like we still have winters. Okay. So why do y'all think we still have winters? Okay. So because the Earth is still on a tilt, and therefore we're still going to have seasons. I heard something else. Okay. Yeah. So the winters are maybe a little bit warmer, about the same, but we're having like weird cold snaps, right? Like we're having a little bit more of a fluctuation. We're having ice storms in areas where we didn't normally have ice storms, but then we also have warm times during the winter. So the winters are a little bit more sporadic than they used to be. And you guys, I mean, y'all are young, and so you haven't experienced a lot of that. I haven't experienced a lot of what the weather used to be like, but it is definitely changing. So basically, the whole idea of global warming is that the average temperature over the course of the year is higher. Okay, so if the average temperature used to be 70, then now it's 72. Okay, so the average temperature is going up because the temperatures in the winter are staying about the same, maybe being a little bit colder at sometimes, a little bit warmer at sometimes, and then the summers are much hotter. Okay. Well, I'm not going to say much hotter. They're hotter, okay, in general. And also the warmer the warmer seasons are a little bit longer. And so therefore, if we take the average from every single day from 365 days, it's a higher number than it used to be because the warmer seasons are longer and because when it's warm, it's a little bit warmer, okay? All right, so that's the whole global warming idea. So the greenhouse effect. I'm going to talk about this picture and then we'll get on to the notes. And I'm not going to be able to get up because I have to stay near my computer since I'm recording, but I'll use my mouse to show you guys. So here's the sun, right? Okay, here's the Earth. And then this is representing the atmosphere. And then this is like all the space inside the atmosphere. So what's supposed to happen is that the sun's UV rays, okay, some of them make it through the Earth's atmosphere. Some of them don't make it through the Earth's atmosphere and bounce back. We'd be in trouble if we didn't have an atmosphere, right? If we didn't have an atmosphere, it'd be like 400 degrees Fahrenheit in the daytime, okay? So it's really important that we have an atmosphere. So some of the UV rays bounce off of the atmosphere. Some of them make it through and the atmosphere kind of dissipates them and they make their way to the Earth's surface, okay? Those UV rays warm the Earth's surface, okay? Some of them are absorbed by the Earth, and that's what warms the Earth's surface and helps us to keep our climate. And then some of them are supposed to bounce back and out of the atmosphere, okay? So the issue here is that because of pollution, there's been a buildup in the atmosphere of oxides of nitrogen, of methane, of carbon dioxide, okay, which are the result of combustion and human processes. And those build up in the atmosphere, and then some of those UV rays that are supposed to leave the atmosphere are not able to. And therefore, now the atmosphere is radiating down heat, okay, more than it used to. So the greenhouse effect is actually supposed to be there. Our Earth's atmosphere is supposed to make Earth kind of like a greenhouse, okay? How the UV rays can make their way in, some are absorbed, some are reflected and go out, okay? That's supposed to happen or else we would freeze to death or during the night and we would be scorched during the day. But the enhanced greenhouse effect is what's causing the average temperature over the course of a year to go up. So the buildup of extra gases which cause more heat to be trapped in than usual. That is the enhanced greenhouse effect, and that's what's causing global warming. Okay, so let's talk through this. So let's see, since the 1800s, humans have produced increasing amount of carbon dioxide from factories. So what happened in the 1800s? The Industrial Revolution. So since the Industrial Revolution, if you look at the bottom of this paragraph, 25% more CO2 in the atmosphere compared to before the Industrial Revolution. So that's a huge increase, and that's part of what's causing the atmosphere to trap some of that heat in that would normally make its way out. Okay, so these are the steps of the enhanced greenhouse effect. So the sunlight enters the Earth's atmosphere, okay, and the atmosphere is transparent to light, and so the light is able to make its way through, okay? And some of the sun's rays are supposed to be absorbed, and some of them are supposed to reflect and go on out. But what happens is that some of that heat gets trapped in along with them. So that extra heat that gets trapped in, that's the enhanced greenhouse effect. All right, and that's mainly as a result of human-generated pollution. I mean, there are some natural effects as well. So some greenhouse gases. So I mentioned carbon dioxide, methane, oxides of nitrogen. So these are all things that are made primarily by human activity. So by cars and use of fuels, fossil fuels, combustion, okay, fertilizers that are being used are evaporating and making their way into the atmosphere, factories and their use of fuel or their method of combustion, production of natural gas, landfills produce methane over time. I don't know if you guys knew this, and this is obviously not human generated, but cattle actually make methane in their digestive tracts. So that would not count as quite a human generated, except for the fact that we intentionally breed and make the cattle, increase the cattle populations for food. So, but that probably kind of balances out. All right, so we've kind of already talked about this part right here, but here are some effects of global warming. So what are some effects of global warming? You don't have to look at this list. Maybe give me some without looking at the list. So what, Caitlin, what did you already say? Warmer water temperature, which is going to cause differences in marine life, right? But also it's going to cause evaporation, okay? What's going to happen, guys, if more water evaporates up, what's going to happen to our precipitation levels? It's going to be higher. There's going to be more moisture, okay? Therefore, more moisture to come down, which is going to mean more floods because there's more rain and potentially more snow during the cold months. Okay, Sarah?
There's going to be a lot more ice melting.
Good, very good. Okay, so a couple of you guys have perpetual ice cover as one of your biomes, okay? That's the Arctic Circle, the area up north where basically the ocean up there has always been really covered by ice caps, by sea ice, and that's like the area where polar bears live, and they actually hunt off of the sea ice. They stand on the sea ice and get their food, and basically not a lot of the ice, but a portion of that ice is starting to melt. Okay, and because a portion of that ice is starting to melt, that's influencing their habitat. It's also, if ice melts, then now there's more liquid water, right? What could that mean for our coastlines?
They're going to get flooded.
Going to move further in, right? So the idea is that over time, because the ice is melting, sea levels are going to rise and the coastlines will move in. Okay, so there's another effect. So melting glaciers, we kind of talked about all this. Extinction of certain species, because if we take away if we make it so that polar bears can't fish, okay, or can't hunt for seals because they can't stand on sea ice because they can't swim for very long, okay? So if they're not able to hunt, then that's endangering those populations even more.
Sea bears.
You think? All right. So then there's this thing called the precautionary principle, and the Intergovernmental Panel on Climate Control came up with it. It's been a while ago, kind of when this first push of like, okay, the temperature's getting higher first started to come out, and they did a lot of research. This panel did a lot of research to see, okay, is global warming really a thing? Is this really happening? And what they found was that the average temperature over the course of the year was increasing, and also the fact that it seems that at least 90% of that change is due to human impact. And the prediction based off of that is that the sea level will rise 18 to 59 centimeters, and that there will be more severe weather, which there is. Okay. Than back in 1988. Okay. And then the precautionary principle, simply stated, is it says that an action should be taken to prevent harm, even if there is not sufficient data to prove that the activity will have a severe negative consequence. So basically, the whole idea is do no harm. So if you're doing an activity which is generating pollution, which is influencing the greenhouse effect, then you should stop. Basically, is what they're saying. And there's some legislation that's actually related to the precautionary principle that has inhibited how businesses can run and how they produce those pollutants. So some human impacts. So we talked about this. More ice is melting. Another interesting thing, if you look at D and E here under human impact. So basically, since the sea ice is melting, and since who had the tundra? I just had the tundra. Remember learning a little bit about permafrost and about the ice up there? Okay, so the tundra is kind of further up north, not quite to the Arctic, but just below that. And in that area, there is a layer of ice under the soil called permafrost, and it's very cold there. It's very specific, the organisms that can live in that type of an environment. Well, it's getting warm enough to where some of the permafrost is melting in the southern parts of the tundra. And therefore, now plants can grow there that didn't used to grow there when there was permafrost everywhere. And so therefore, new species can move in. Well, that's really altering the tundra, right? That means that in 50 years, AP biology classes could be learning about a totally different tundra because it could look really different from how it does now, because new species can move in because the permafrost is melting. Yes, Ben? Sure. All right, so I'll give you a couple of examples of some shrubs that are moving. There are birds that are moving to different places, and they're moving into these areas where people have never seen them before. They're like, where do these robins come from? I've never seen those before. And they're moving in because now the climate is different, and they're able to exist in these different environments. Yeah, and I already really talked about the sea ice, so you guys can look through this. That second to the last point there, as temperature rises, habitats from the south are moving northward, bringing in mosquitoes and robins. So basically, mosquitoes used to be a main issue in the south. Okay, it's starting to become a little bit of a northern issue as well because their warmer months are getting warmer. Does anyone know how mosquitoes reproduce? What type of environment do they need?
Lay their larvae on something.
They do. Stagnant water. Good. Okay. So they do. The females lay their larvae in the stagnant water, and then the males basically just fly above it and drop the sperm. And then there's thousands of mosquitoes. Okay. So flooding would cause, if the temperature is getting higher and the water is getting warmer and it's evaporating, then now we've got more precipitation, we've got more flooding, therefore we have more mosquitoes and insects to deal with. So there's an increase in the mosquito population. Okay, all right, so I'm going to leave us there. I think I talked about all of everything that's in here, at least conversationally. So